guys, so today we're going to look at lesson 1.4. We're going to be looking at solving equations in three variables. Okay, so we have some vocabulary and some steps up here, and then I plan to work through 3 or 4 problems. They are kind of longer problems for us to work through today. Okay, so linear equation in 3 variables. X, y, and z is an equation of the form ax plus by plus cz equals d, where a, b, and c are not all 0. A system of 3 linear equations. So this is just an example, but the types of problems we're going to look at today look like this, where you're going to be given 3 equations, and each equation has 3 of the same variables, x, y, and z for the most part, but we can use whatever letters we want. Okay. Solution of a system of 3 linear equations is in order triple, and we put them in alphabetical order, x, y, z. All right, order triple x, y, z, whose coordinates make each equation true. So when we get our solution x, y, z, that means we can plug each of those back into all 3 equations, and it will satisfy each of the equations. Now our steps, it's going to sound a little confusing until we work through a problem, and then if you came back and read the steps, I think they'll make more sense. Step 1. You're going to pick any 2 equations. So for example, let's say I picked these 2 equations, the first and second one. And then you pick, everyone can pick differently, you pick which variable you want to eliminate. So let's say I want to get rid of the x's. Now you have to remember back in Algebra 1 when we worked with systems of equations, if I want to get rid of the x's, I'd have to multiply this equation through by a -3, so that a +3 and a -3 would cancel when I add the equations together. So I'd multiply -3, -3, -3, -3, and I'd add the columns together, and that would eliminate the x's. That would leave me with an equation, a new equation with just y and z. All right. Then what you're going to do is you're going to repeat step 1, but picking 2 new equations to work with. So what I mean by that is the first time I worked with these 2 equations, the second time I can work with the first and the third, or the second and the third. Okay. So I'm going to have to work with one of the same, but then combined with a new one. So let's say I pick the second and the third to work with. I still want to eliminate the same variable, and that's important. So if I eliminated the x's the first time, I want to eliminate the x's again from these 2 equations. So I'd multiply this equation through by a -4, okay? And that would give me -4x, which would cancel when I add my columns together. And that will leave me with another new equation with just 2 variables, and the same 2 variables I got last time, which is just y and z. All right, so now you're going to take your 2 new equations with only 2 variables and solve using substitution or elimination. So now it's an Algebra 1 problem, okay? You're going to solve using elimination and substitution just like you did in Algebra 1. Once you do that, you'll have, for this example, you'll have an answer for what y is equal and what z is equal to. So what you do is you substitute the values you found in step 3 into an original equation to find the remaining variables. So once I have my answer for y and z, I'm going to plug them back into one of the original equations. That way I can solve for x. Okay? Now the tricky thing here is we all can approach the problems differently. Okay? Your friend next door could have gotten started by saying, I'm going to work with the first and the second equation, but I'm going to eliminate the y's. And then the next person could say, I'm going to work with the first and the second, but I'm going to eliminate the z's. So there's so many different options of how to approach the problem. Kind of makes it hard because we can all be doing the problem differently. What you need to be careful about is just a simple algebra. Distributing, sign errors, addition, subtraction errors, that's what kills people with this lesson. So you have to pay attention, work thoughtfully, double check your work, but just if you're paying attention and really focusing on each step and being careful with your signs, your multiplication, your addition, and subtraction, you really shouldn't have a problem once you get a hang of how to approach the problems, okay? Now, as you're working, if you get an identity, so if you get 0 equals 0 at any point, you can stop and say that the problem has infinitely many solutions, okay? Likewise, if you get something that makes no sense, if you get like 5 equals -2, you can stop and say there's no solution. I'm going to try to show you an example of each, okay? So let me just erase the board and get our first system written up there. All right, so my first system, I'm going to have the first equation is x plus 2y minus 3z equals 11. My second equation is going to be 2x plus y minus 2z equals 9. And my third equation is going to be 4x plus 3y plus z equals 16. Okay, so your first step is to pick two of the equations, and that's why I numbered them, so we can just call them 1, 2, and 3. Pick two of the equations and pick which variable you want to get rid of. Again, at this point, everyone can do something different. I'm going to pick equation 1 and equation 2, and I'm going to eliminate the x's. So if I want to eliminate the x's, they need to have opposite coefficients, meaning positive 2 here, it's already there, so I need a negative 2 there. So if I want a negative 2, that means I have to multiply everything by a negative 2, okay? So I'm going to show that I'm doing that, and these are the steps that a lot of people want to just do quickly in their head, but I strongly urge you to write them out because I'll show you the one spot where people make mistakes. A lot of times people will multiply negative 2, negative 2, negative 2, and then forget to do it on the other side of the equation. So even though it might seem a little elementary to do it this way, writing it out and drawing your arrows will help you not make that mistake. So it's negative 2x minus 4y plus 6z equals negative 22. And then I'm going to copy this equation down just as it is underneath, 2x plus y minus 2z equals 9. Because remember, I said I wanted to eliminate my x's, so when I add my columns, the x's are eliminated. And negative 4 plus a positive 1 leaves me with a negative 3y. A 6 plus a negative 2 leaves me with a positive 4z. And a negative 22 plus a 9 leaves me with a negative 13. All right, so I like to star that equation so I don't lose it. Now again, I have an equation with just a y and a z. I need another equation with just a y and a z. So I have to go back to the beginning. I have to pick a combination of two new equations, so I can't work with 1 and 2 again, I already did. But I can work with 1 and 3 or 2 and 3. And because I eliminated my x the first time around, I have to again eliminate the x's. So I'm going to work with the first and the third. So if I have a positive 4 here, what do I want there? I want a negative 4. So I'm going to multiply everything through by a negative 4. Okay? So, again, I know you probably don't want to do all the writing that I'm going to do, but I strongly suggest it. Write down the first equation. Write down the third equation. Be careful with the copying, that you don't make sign errors or anything like that. Now I'm going to show that I'm multiplying through by a negative 4. So I'm going to multiply everything in that first equation by a negative 4. And when I do that, so negative 4 times x is negative 4x. Negative 4 times 2 is negative 8y. Negative 4 times negative 3 is a positive 12z. And negative 4 times 11 is a negative 44. The other equation, number 3, doesn't change. So I copy that down. 4x plus 3y plus z equals 16. Okay. All right, so get color that shows up a little better maybe. Now I'm going to combine my rows. Remember, the goal was to eliminate the same variable that I did above, which it happened, it worked, right? So now I have negative 5y, 12, sorry, the glare is bad, plus 13z. Remember, you're adding here. And then you're going to have a negative 28. Just double check that I have it all right. Yep. All right, so now I call them my 2-star equations, my 2 equations which only have 2 variables, and they're the same variables. So I'm going to write them down in the middle here. So I have negative 3y plus 4z equals negative 13, and negative 5y plus 13z equals negative 28. Now this is an Algebra 1 problem. I still have to solve by either substitution or elimination. So I need to eliminate, I like elimination usually more than substitution, but I'm going to eliminate either the y's or the z's. All right, I can see very quickly that a common multiple between 3 and 5 is 15. I can make this one a 15 by multiplying through by 5, and this one a 15 by multiplying by 3. If you want to make one a positive 15 and one a negative 15, just change the signs of one of them, which I'm going to do. All right, so I'm going to multiply the top one by a negative 5. The bottom one, I'm just going to multiply by a positive 5. So that way they have opposite coefficients. 13z equals negative 28. All right. So when I do that, I'm going to have 5 times 3, negative times negative is a positive 15y. Negative 5 times 4 is a negative 20z. And then negative times a negative is going to be a positive, and you're going to have a 65. All right. Multiplying everything by a positive 5 in the bottom. A positive times a negative is a I wrote the wrong number though. See how easy it is to make mistakes? That should be a 3, not a 5, because I wanted 15 there. So 3 times negative 5 is negative 15. 3 times a 13 is a positive 39z. And 3 times negative 28 is a negative 84. All right, you're going to add and eliminate the y's. Okay, the y's are eliminated. Negative 20 plus 39 is a 19z. And 65 and negative 84 is negative 84 is a negative 19. All right, divide both sides by 19. And you have z is equal to negative 1. So once you have the value of z, pick one of these two, one of your star equations, pick one of your star equations to plug the z back into to solve for the y. All right, so it looks like I chose the first equation, right? So if I take negative 3y plus 4z equals negative 13, now I can plug the z in here. So I have negative 3y plus 4 times negative 1 equals negative 13. Negative 3y minus 4 equals negative 13. Add 4 to both sides, so it's going to be negative 3y equals negative 9. Divide both sides by negative 3, and you're going to have a positive 3. All right, so we know y, we know z. The only thing we don't know is x. So you're going to take your y, your z, and plug back into one of the originals, and it's up to you. I'm going to work with the first one, just because the numbers are smaller. Work with the first equation in order to find x, okay? So I'll write x plus 2y minus 3z equals 11. My y is 3, my z is negative 1. So it's x plus 2 times 3 is 6. And then negative 3 and negative 1 multiplied together is a positive 3 equals 11. 6 and 3 gives you 9. So x plus 9 equals 11. So x is equal to 2. When you are done, your answer is in ordered triple. We put it in alphabetical order, x, y, z. So your answer is 2, 3, negative 1. And that would be your final answer as an ordered triple in parentheses. All right, so yes, multiple steps. But once you get a hang of the process of, I take 2, eliminate a variable, pick a different 2, eliminate that same variable, take my 2 new equations, eliminate a variable, and then just substitute back in, right? And as long as you're paying attention to your signs, your multiplication, your addition, your subtraction, copying things carefully. Another big thing is like being able to read your own handwriting, okay? Don't confuse Z's with 2's and stuff like that. If you kind of have sloppy your handwriting, you need to focus on that as well. Okay, let's see if we can work through another one. So that one had answers. I'm going to look for one where maybe it's infinite solutions or no solutions. Let me get this erased. All right. Okay, so equation 1 for this example is x plus y plus z equals 4. Equation 2, x plus y minus z equals 4. Equation 3, 3x plus 3y plus z equals 12. All right, so I'll continue to do elimination instead of, I was going to do substitution, but I'll just stay consistent. All right, so let's say we're going to pick equation 1 and equation 2 and eliminate the eliminate the z's. I chose z's because one's positive and one's negative. They already can be eliminated. I don't have to multiply by anything. All right, so let me rewrite the equations one on top of the other. So I have x plus y plus z equals 4. This one as well. X plus y minus z equals 4. Eliminate the z's. So I have 2x plus 2y equals 8. Okay, step 2. Pick a different pair of equations. So I just worked with 1 and 2. My options are to work with 1 and 3 or 2 and 3. And eliminate the same variable. So I'm going to work with 2 and 3 and eliminate the z's again. I chose 2 and 3 because one's negative, one's positive, so I don't have to like multiply through by anything. Okay? So, since I don't have to multiply through by anything, I'm just going to copy equation 2. X plus y minus z equals 4. On equation 3 is 3x plus 3y plus z equals 12. I'm going to add them together to get 4x plus 4y, the z's are eliminated, equals 16. Okay, so those are my new equations that I'm now going to work with. So I'm going to stack them up on top of each other down here. 2x plus 2y equals 8. And 4x plus 4y equals 16. Okay. Now I have to eliminate again. So you either have to eliminate the x's or the y's. I'm going to say I'm going to eliminate the x's. I'll eliminate the x's by multiplying this one through by a negative 2. All right, if I multiply by a negative 2, one will have a negative 4x, and this is a positive 4x. So negative 2, 2x plus 2y equals 8. So when I multiply by a negative 2, I have negative 4x. Negative 2 times positive 2, negative 4y. Let me not do an equal sign there, sorry guys. Arrow. And then negative 2 and an 8 is negative 16. This equation stays the same. 4x plus 4y equals 16. Let's add them together. And what happens? Eliminate, eliminate, eliminate. So you're left with 0 is equal to 0. Remember I said if you get an identity, that is an identity, you can stop because the system has infinite solutions. Okay? So you can stop. You don't have to do anything more. And you can say infinite solutions. Okay? All right, guys. Let me see one more, or I might do a word problem. Let's see what I have here. Yeah, let me do one of the word problems. So, let's do this one. Okay. This will be the last problem for today. Now, I didn't do one with no solutions. Again, if you come across something that makes no sense, if you are working through the problem and you end up getting like -2 = 5, like something that doesn't make sense, no solution. Okay, and we'll talk about that, I'm sure, when they pop up in homework. All right, so for this example, it says you found $6.60 on the ground at school. All in nickels, dimes, and quarters. You have twice as many quarters as dimes, and 42 coins in all. How many of each type of coin do you have? How many of each type of coin do you have? All right. So just like most word problems, let me see if, I don't know if that's better or worse, guys. The lighting in the house is not the best. No, there's huge glare right in the middle, but we'll have to make do. Okay. So here we have a word problem. And the first thing we always do with word problems is define our variables. So that's what we're going to do here. Instead of x, y, and z, we'll use n, d, and q since we're talking dimes, nickels, and quarters. So we're going to say let n equal number of nickels, d equal number of dimes, and q is going to equal number of quarters. Okay. Then we have to come up with our system, okay? So being that we're working with 3 variables, we should be looking for 3 equations. One equation is going to have to do with the value of the coins. Another equation is going to have to do with the number of coins. And the third equation is going to have to do with some relationship that's stated in the problem about having more of one versus the other, okay? So let's just start with the value of the coins. We know a nickel is 5 cents. So 5 cents times the number of nickels plus, I don't know how many dimes I have, but I know each dime is worth 10 cents. So 10D plus quarters. I know each quarter is 25 cents. So I'm going to take all the quarters I have Q and multiply by 25 cents. Now when I add that all together, that's going to equal the total amount that I have, which is 660. Notice I didn't use 0.10, 0.25, and 0.05. I moved the decimal place 2 spots in each of the coins. So I'm going to move the decimal spot 2 places and make it 660. 660, sorry. If you want to make it 6.60, then this needs to be 0.25, 0.10, and 0.05. I don't like to work with decimals if I don't need to, so we're going to leave it like that. Okay. Now it says that you have a total of 42 coins. So you take the number of nickels you have, you take the number of dimes you have, you take the number of quarters you have, and you're going to add them together to get a total of 42 coins. So again, equation 1 has to do with the value of the coins and the amount of money you have. The second equation just has to do with the number of objects you have. Nickels are an object, so object, 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 42 total objects, okay? The last equation has to do with this part here. You have twice as many quarters as dimes, and you have to be careful here. This is where students make the most mistakes, okay? you have twice as many quarters as you do dimes. So let's just think about an example. All right, let's say that you have 10 dimes, okay? If you have 10 dimes, how many quarters does that mean you have? Okay, well, if you have 10 dimes and you have twice as many quarters, that would mean that you have 20 quarters, right? What if I say you have 5 dimes? How many quarters do you have? Well, you have twice as many, so that would mean that you have 10 quarters. I'm just using random examples that have this relationship to illustrate a point, okay? We're going to write an equation, and the equation is going to say something about them being equal to each other, right? An equation has to have an equal sign. In order for your dimes to equal your quarters, what would you have to do? In order for the dimes to to equal the quarters, what would you have to do? Well, look at this relationship and think about that question again. In order for the 10 dimes to equal the 20 quarters, you have to multiply the dimes by 2, right? In order for your 5 dimes to equal the quarters, you'd have to multiply your dimes by 2. So it's kind of opposite of what you might intuitively think, because here it says you have twice as many quarters as dimes. A lot of students want to write 2q equals d. Well, that's not right. It's 2d equals q. You have to double your dimes in order for it to equal your quarters. Okay, think about that again, and think about this the examples I wrote, and it will make sense. Okay, so there is my third equation. 2d equals q. All right. So this problem is actually going to be solved a little bit differently than the other ones because I can use substitution instead of elimination. I tend to only use substitution if a variable is already isolated. Since the q is already isolated, wherever I see q, I can replace it with 2d. And then these two equations will only have n's and d's. So I'm going to take the first equation, and I'm going to write 5n plus 10d plus 25, but instead of q, I'm going to substitute in 2d, because that's what q is equal to, equals 660. And then the second equation, n plus d plus, and instead of q, since q is equal to 2d, I'm going to replace it with 2d, is equal to 42. So now I can clean up equation 1 and equation 2 and just have n's and d's, okay? So equation 1 becomes 5n plus, all right, so 25 times 2, that's 50, plus another 10, 60d equals 660. And equation 2, I'm going to have n plus 3d equals 42. Okay. All right, so now what you need to do is you still need to eliminate a variable. You can eliminate the n's or the d's, it's up to you. You'd have to multiply to get a -5 there, or you'd have to multiply to get a -60 there. I'm going to multiply this second equation by -5, okay? So I'm going to have, this equation stays the same, 5n plus 60d equals 660. Multiply the second equation through by -5. Oh, I should have written that one over further. I'm going to have to do it in my head and then write it down. Sorry, guys. I didn't leave myself enough room to show the math. All right. So if I multiply by -5, it's -5n. Multiply by -5 here, so -15d. And then multiply by, got to do it over here, make sure I don't make a mistake, 20, 21, 210. All right. And then I'm going to add, and that'll eliminate my n's. Okay, so 60 minus 15 is 45d. Oh, 5. 45d. And if I'm adding, everything's positive. Oh, did I forget a negative? I did. See, guys, it's so easy. That's a -210 because I was multiplying by -5. All right, so if I subtract 210 from 660, that's going to leave me with 450. Divide by 45, so D equals 10. Once you know that D equals 10, you can plug back into one of these equations. Where am I? One of these equations if you want to solve for n. Okay, so let's plug into this one here. So I have n plus 3d, it's an n plus 3d equals 42. Right, I'm taking this equation right here. So plug in the 10, so it's 3 times 10 equals 42. So n plus 30 equals 42. N equals 12. And then finally, to get Q, 2 times D equals Q. So Q is equal to 2 times the 10, right? So Q is equal to 20. All right, so I ran out of room, but you'd write your answer as 10 dimes, 20 quarters, and 12 nickels. Okay? All right, guys. I know that was a little bit of a long lesson. These problems do take a little bit of time and a lot of space, so go ahead and finish up your notes, and I'll see you back here for the next lesson. Bye.